Okay, so we've got another example here of a graph that we don't know, and we're just going to work out how we would go about drawing it. So if we look at this one, even if we didn't know from the video title what type of graph it was, we could have a pretty good idea just by looking at it, actually, because this one's almost perfectly in its kind of general form of these graphs we've been looking at. If we look at this, it's got some perfect square with y, some perfect square with x, and there's subtraction between them. That subtraction sign tells us that it's a hyperbola, not an ellipse. We can also remember, just from our little kind of neat trick, that if you've got your y term as the thing in front of the subtraction sign, so the bit that's positive, we know that it's going to be the type of hyperbola that opens upwards. So it looks something like, I'll just turn my pen on, something like that, with like a center point and some asymptotes. But let's have a think about what we would do to go about graphing it. The first thing I do is fully put it in standard form. So for one thing, on the right-hand side, we've got it equaling 4, not equaling 1. We like it to equal 1. So let's divide everything through by 4, and we'll see what we get. So we get y plus 1 all squared. If we divide that by 4, well, part of the 4 will cancel with 2. We'll be left with just 2 on the bottom. Take away x minus 2 all squared all over 4 equaling 1. Now, we also like the things on the bottom, so a and b, to be written as squares. So if you think about it, if you want to do that, all you have to do is think, well, nothing squared gives me 2, no whole number squared gives me 2, but the square root of 2, if I were to square that, I would certainly get 2. So we can write on the bottom there, root 2 all squared, and then with x, we've just got, well, I know that 2 squared is 4, so 2 squared equals 1. You might want to put that in brackets as well, just because it's nice and helps avoid making mistakes. Now, from here, we can get into doing quite a bit of the graph. But before we do, it might be worth putting in working out what the asymptotes are first to help kind of guide your drawing. But I suppose the one thing we can do before we do that is just look at the graph and work out what the point is. So, or look at the equation rather. So if I look at that, well, the h value, the horizontal shift, is positive 2, because remember it's always x minus h, so we can kind of just ignore the negative sign. And then for k, it must be minus 1, because it's normally y minus k. So just minus 1. So I'm at 2, negative 1. So that would be down here. That is my center point. Great. So that'll come in handy later, but let us do the asymptotes. So I might just grab this, take it down to my extra workspace down below, and get into it. So in terms of finding the asymptotes, there is an equation to do that, which some of you might remember. I personally don't like memorizing things, so I don't remember it. What I do remember is the little trick where if I want to get the asymptotes, all I can do is I can just grab the first bit of the equation. So I'm just going to do that here rather than write it again. I'm just going to go grab and copy and paste it below, and going to do the same thing for the x bit. I'm just going to ignore the negative sign, ignore the 1, and all you do is, so you've grabbed the 2 bits, put an equal sign between them, and then you solve for y, and you're going to get 2 equations, which are the equations of the asymptotes, and you'll get it in terms of y, which is quite nice, kind of what you expect. So if I do that, well, first of all, what I'm going to do is I'm going to times everything, both sides, by the square root of 2 all squared. So I get root 2 all squared, x minus 2 all squared all over 2 squared. Now, if I look at that little expression on the right, I can see that actually everything is in terms is squared, right? So what I could do is I could just take that out, so to speak. So have in brackets everything in there, just without the squared, and have the squared on that side. And you'll see in a sec, I'm going to do that. It's going to make the next step a bit easier. So 2 down the bottom, if that isn't quite clear. Right, and that still equals y plus 1 all squared. And if we grab that and take it to a place with a bit more space, what we can do is we can just take the square root of both sides, and because you've got just something that's all squared, that is actually going to be quite easy to work with. So if you think about taking the square root of both sides there, well, this side will just become y plus 1, and this side, you need to remember your plus or minus sign, and because it's all squared, you just get the stuff that's left inside. You just kind of get rid of the square on the outside, squared sign on the outside. There we go. And now, so we've almost got the rule. It's just y equals minus 1 plus or minus all that mess. Root 2 x minus 2 all over 2. Now, in terms of drawing lines, that is not a form that I'm used to seeing. I'm used to seeing y equals mx plus c. So what I'm going to do is I'm going to write it in that form. So think about it. The gradient, m, is going to be, well, one of them is going to be plus root 2 on 2 times x, yeah? And then so if I'm taking the positive one, the next bit will be minus 2 over 2, so it's just minus 1, minus 1. So if we think about that, we could just get rid of that and just draw in. It's really just take 2, right? For the negative bit, so we'd have negative root 2 on 2x. Then if you think about expanding that bracket, you'd have plus 2 all over 2. So you'd have plus 1. And then you'd have, so you'd have plus 1 on the end, and you also can't forget your negative 1, so we got plus 1 minus 1, i.e. nothing. So we can just get rid of that as well. So just rub that out. And now we have our 2 equations of the asymptotes. And as it happens, I happen to know the value of root 2 over 2 because it's one of our treaty exact values, and I've seen them a million times. So I have committed them to memory accidentally. And it's about 0.7. It's like 0.707 something. So we've got our asymptotes. I'm just going to cover up this whole bit. Got our asymptotes, got our center point, and we roughly know what they look like. Just clearing this all away. So at the center point, so we know that the asymptote is going to go through that center point, then this equation, so it's got a gradient of about 0.7, so it's about a gradient of 1, and it goes through minus 2, so drawing in our asymptote is going to look something like this, and up there. And then the other one is just going to be the reflection of that through the center. So it goes through the origin because it doesn't have a c value, a y-intercept term. So it goes like this. Great. Now we just need to actually draw in the hyperbola. What I would do is I would draw in the vertices. If you remember, they're to do with the a and b values. So a here is 2 and b is root 2. And because this is a vertical one, because y is the positive one, it's just going to be from the center point plus or minus b. So in this case, plus or minus root 2. So if you think about it, if you're adding root 2, about 1.41, or minus 1 plus 1.414, so it's about 0.414, right? So it's about here, right? We're going to have our vertex at 2 minus 1 plus root 2. You certainly don't have to memorize things like the value of root 2. You just have to be able to approximate it in your head. Don't worry about me having memorized them. It's nothing worth bragging about. The next one. So it'd be what? 2 and then minus root 1 sorry, -1 minus root 2. So it's like -2.4 would be like down here. Okay, so you got your vertices. I'll just label this one, 2 minus 1, take root 2. And then you've got your asymptotes. So all you got to do is draw it in and make it kind of hug the asymptotes. Don't let it kind of kick up. So I'll see how I go with drawing this. Like that. And like that sort of thing. And then also here. So going towards the asymptotes. You can probably do a better job than me. But yeah, it looks something like that. Right. I think that'll do us.